Alright, so I think things are going here. I just wanted to make a quick video on how to use Octave Online to, um, what am I trying to do? Compute eigenvalues and eigenvectors. Alright, so the example I want to work with is the matrix A, and that's the 1, 2, 3, I'll say 2, 4, 5, and 3, 5, 6. So if you're going along, 3, 5, 6, if you're going along with how do I get rid of some of this stuff? There we go. Can I get rid of that too? Okay, we'll just try that. Okay, there we go. This is the matrix A we're going to be working with. I want to find the eigenvalues and eigenvectors. And so rather than just type the command eig, I want to actually find like the characteristic equation. And so the characteristic equation is found by using the poly command. And so I will write p just to store the polynomial, poly, and then the matrix A. Now when I type this, you'll notice that I'm getting four numbers. Those are actually the coefficients of the polynomial, of the characteristic polynomial. So in other words, the 1 represents the coefficient of lambda to the third power, and then minus 11 lambda to the third power. Then, oops, did I say that right? We have a 3 by 3 matrix, so the polynomial has degree 3. So this is 1 times lambda cubed minus 11 times lambda squared minus 4 times lambda plus 1. Okay, and so then the next command will be to find the roots to this polynomial. And so I'm going to maybe label the roots as L. I guess I could have used R. Oh well. Roots, and then the polynomial is P. Okay, and then those are the roots. Notice that those are stored in the vector L. So if I just want the first one, I could say like L1, and that would just give me the first value. Similarly for L2, that would just give me the second, and so on. Okay, and now I want to form the matrix A minus lambda I. And so the way to do that, I'm going to go ahead and put that into a matrix B. So that's going to be A minus the lambda, in this case is L1, times the identity matrix. I need a 3 by 3 identity matrix, and so the command is I. E-I-E-Y-I. Okay, it's kind of a weird way to put that. So, okay, so there's the matrix. So B is the matrix with lambda I subtracted off the diagonal. Good. Now there's several ways we could do this. We could take the null space of B, right? And that gives me a vector. So that's a vector in the null space. And so this is, by the way, is telling me that it's one-dimensional, and that's the basis. Another way to do that is just to take the row reduced echelon form of B. And sometimes that's a nice way to do it as well, because here you see automatically, right, there's one free variable, x3 in this case, and we're writing x1 as 0.445 times x3, x2 is 0.8019 times x3, and then x3 is x3, and then you could write the vector. Okay, so that's kind of nice. Notice that these two vectors don't look very much alike. How do I get like this vector on top here, the one that's 0.38328, to look like the bottom? Well, these are scaled differently. Remember when I just read off what I would write for this vector at the bottom? I had a 1 at the last entry, and so here I have 0.737. So I'm going to divide this vector up at the top by 0.737 to get a 1 here, and that should automatically scale the other two elements. So let me try that. So let's see. Maybe I'll write V as my null space of B real quick. So so V is my vector now, and so I'm going to take 1 over V3. I'm going to multiply that times V, and let's see if we get the numbers we expect. Oop, we spun out of there. Okay, you see the 0.445? I'm going to have to scroll up and down a little bit there to see it. I was trying to get this window as big as I possibly can. Whoops, I think I just scrolled that right out of your sight. I forgot that I was recording a certain window. Okay, so you'll have to trust me that that is the vector that we expected. Okay, good. Next, we are going to just compute the eigenvectors and eigenvalues using the eig command. So that's just eig a. Okay, and then this is the eigenvector that we got before too, 0.380, 0.591, 0.737, and that corresponds to this matrix here, or this eigenvalue. But of course, when we're asked in the homework to do these using the computer, I really want you to compute the pieces of the eigenvalue computation, right? So compute the characteristic polynomial, get the roots, and then for each of the roots compute the null space or the reduced echelon form. Good. Okay, so that's how we compute eigenvectors and eigenvalues. So the three new commands that we talked about today are the poly command. So when you input a matrix, you output the coefficients of the characteristic polynomial. The roots command we haven't used before. That finds the roots of the polynomial p, and the polynomial is defined by its coefficients. So it assumes that the coefficients are of the right form there. And then finally, we compute a minus lambda I. And so remember to use this I3 for that identity matrix. And then finally, we can find the null space or the reduced echelon form of that matrix. Okay, so then you can, I will leave the other ones to you. They're just the same commands. All right, so if you have any questions, be sure and ask. Otherwise, I will talk to you later.